This is a demonstration on insulators for the S1 energy and heat topic. So first of all, the equipment. Got a digital thermometer, got a ruler, a metal can with the lid cut off, a plastic lid for the metal can, a stop clock, a big measuring cylinder, and a kettle. Also a bench mat, and a ton of bubble wrap. You may wonder what we're going to do in this experiment. Well, what we're going to do is get this can, fill it with boiling water, and then wrap it in different thicknesses of bubble wrap to see how much the different thicknesses make a difference to how good an insulator it is. You may be thinking that this tin can won't put out much heat because it's silver and reflective. You'll be thinking it's not going to release much radiation, but metal is also a very good conductor of heat, remember. So what will happen is the can will get very hot and it will start to conduct the heat to the air around it. That heated air will then convect away, allowing more cold air to come into contact with the can and slowly cooling down the can. Bubble wrap helps because, as you can see, the air in here is trapped in pockets, so the heat won't convect away. Air is actually a really poor conductor of heat. That's why bubble wrap will help keep things warm. An important part of any experiment, though, is to ask the question, what if we did nothing? So for the first part of this experiment is going to be the tin can with boiling water in it, but no bubble wrap at all. I've changed the camera angle so you can see the setup a bit more clearly. So what we've got here is our digital thermometer, stuck in the lid of the can, on a bench mat, and a timer. Why we're using a bench mat is because this is also a very good insulator, and we've also got the lid because all we're caring about is the thickness of the bubble wrap that will be on the outside of this. We want to keep things fair. Another way to keep things fair is to make sure we always add the same quantity of boiling water to the can. So for this case, I'm going to use 350 millilitres of boiling water. So I'll go and boil the kettle and I'll get back to you when I'm ready to pour. So I've got my boiling water and I'm ready to pour it into the can. Now I'll quickly stick the lid on, let the thermometer read its highest reading, and then start the stop clock when the thermometer is stabilised. The thermometer looks to have reached its maximum, so let's start the stop clock. I'm going to go for 5 minutes for this experiment. So that's been 5 minutes, and the temperature is now 82.3 degrees Celsius. So now I'm going to repeat exactly the same experiment, except this time I'm going to have a layer of bubble wrap on the outside of the can. Then I'll repeat it for 2 layers of bubble wrap, 3 layers of bubble wrap, and 4 layers of bubble wrap. I won't bother showing you all of those because it's exactly the same setup. Each time I'll make sure to note down the initial temperature and the final temperature after the same amount of time as I used in this experiment. Told you the setup would look exactly the same. This time it's got the bubble wrap on it. You may think that the number of layers of bubble wrap is not the most scientific unit, and you'd be correct. So here you are, different thicknesses of bubble wrap measured with a ruler. These are in centimetres. This first one is for 1 layer of bubble wrap. Now 2 layers of bubble wrap. 3 layers of bubble wrap. And finally, 4 layers of bubble wrap. So here's my final results table, but I'll leave you to work out the change in temperature. You may notice some of the results are not exactly as you would expect, so you might want to think of ways I could improve this experiment in the future.